So when you have the odd powers on sine या cos, so how to handle that? इसमें before we go into that, you need to remember, you need to learn that like there was a formula that when there was f dash of x over f of x dx, that is ln f of x plus c. Okay, there was one more formula that I gave to you people, that is when there is f to the power nx times f dash of x. Now this will be used a lot in your further mass integration. So this is going to be um, f of x raised to power n plus 1 over n plus 1 plus c. Now where did we get this formula? Now suppose you have to differentiate, um, x squared plus 1 raised to power 4. Okay, what is that? There is going to be 4 into x squared plus 1 in to the power 3 times 2x. Okay, now this 2x is the derivative of the expression that has a power, over here. Okay, now if you want to integrate x squared plus 1 whole cube times 2x dx, you can simply say, yes, I have this expression which has a power and the next to it is a derivative. So you will write it as x squared plus 1 to the power 4 over 4. And you can see that this 4 will be cancelled with by this 4 if it was exactly 4 written over here. Okay, let me write 4 over here. So you see that you get your expression back, which was x squared plus 1 to the power 4. Now instead of this, if I ask you to integrate, just let's say you are asked to integrate this x squared plus 1 whole cube dx. Now there is no direct way to integrate this. We are just like, blank over here. You might have put a 1 over here, or you might have to think about a substitution to integrate this. So this is a difficult one to handle because the expression that has a power on it, it does not have its derivative next to it. Okay, so you have to learn this really well, that whenever there is an expression, it has a power on it, and next to it you have its derivative. So you can simply write this as f of x to the power n plus 1 over n plus 1. Now there is a very frequently solve example, like for example, if there is cos square x and then there is sine x, okay, or maybe there is tan cube 2x and then there is secant square 2x. There is there may be e raised to power 2x minus 1 raised to power 5, and then there is e raised to power 2x dx. Okay, and with very minor changes in them, you can manage to give its answer, its integral, just one line. Now cos has got a power on it, its derivative is minus sine x. So you put a minus here. So this is going to be minus cos cube x over 3 plus c. Look at this. Tan 2x has got a power on it. So what is the derivative of tan 2x? That is 2 secant square 2x. So I'll be adjusting it like this, like half, and then I multiplied by this 2, so that we have exactly the derivative of this tan 2x over here. Okay, so this will give us half tan to the power 4 2x over 4 and then plus c. Okay, and similarly if you look at this one, e raised to 2x minus 1's derivative is 2 e raised to 2x. So I'll be writing a 2 here, and I'll be writing a half here. So this is half into e raised to power 2x minus 1 raised to power 6 over 6. Now do not think that where did this go. Now we have been able to integrate it because of this term over here, because this is the derivative of the expression which is here inside this bracket. So remember that whenever you have f to the power nx and it has as a product, this has its derivative next to it, so this can simply be written as f to the power n plus 1 x over n plus 1 plus c. Okay. Now going back to the question where we were discussing that how to integrate an odd power on cos or sine. This is cos cube dx. Okay. Now, if you write this as cos x, cos square x, in fact, into cos x. Now, why do we do this? Because we know that this can be written as 1 minus sine square x times cos x. Okay. Now I expand this. This is going to be cos x dx, then minus this is sine square x cos x dx. You got this? Cube is easy, Nisha. Now you see that this integral of cos x will be simply sine x. And now we have the situation here, like sine has got a power on it, and the derivative of sine is cos x. So you can write it as minus sine cube x over 3 plus c. Okay? Even if you have, like if I take you to the next page, like suppose if we have to integrate sine to the power 5x. Okay? Now, sine to the power 5x is going to be, we shall write it as sine to the power 4x times sine x. Okay? Look at this. This is going to be sine square x, and then there is a square. We have sine x. Okay? Now this is going to be 1 minus cos square x to the power 2 and times sine x. Okay? And then this would lead to, we expand this as 1 minus 2 cos x plus cos square x. Oh, sorry, this is cos square x. This is cos to the power 4x, okay? And this is sine x over here, okay? Now this becomes sine x, okay, minus 2 cos square x sine x plus cos to the power 4x sine x. Okay, let me split it like this. Okay, so you see that we can directly integrate this. This is going to be minus cos x. Okay, the next one, there is a power on cos. Okay, and what is the derivative of cos? It is minus. So if I make it plus and I write a minus here, okay, so this can be plus 2 cos cube x over 3. And then again, cos to the power 4x. There's a power on cos and we have its derivative next to it. I just make it minus sine x and I put a minus here, okay? So this becomes minus cos to the power 5x over 5 plus c. Do you understand this, Bachu? Yes?
Yes, sir.
Okay, now you try doing this. Uh, that is cos to the power 4x. Maybe let me make it cos to the power 4 2x. Try integrating this.